Okay, this is just a quick tutorial on how to analyze your mass spec. I'm using MS Paint with a mouse, so please forgive my handwriting. Um, the first step that I would recommend is getting your molecular weight. Normally, that's going to be the biggest peak in the rightmost group, but for some reason, that's not the case with my MS. So my TA has just given me the fact that the molecular weight is 140. So this means that 140 is your molecular ion peak, which is going to be important when you're calculating the amount of carbons you have in the future. But one thing you can quickly notice from this rightmost group is if you have an M+2 peak, which in this case I do, so this is, this is your M peak, this is M plus, good lord, plus 1, this is M plus 2, and way down here is your M plus 3. So, when you're calculating, when you're looking for halogens, first off, you should look at your M, and if you have an M+2 peak, you should look at that. In my case, the M peak is about 3 times as taller than the M+2 peak, which indicates a chlorine. So if you have a 3:1 ratio, that means you have Cl. On the other hand, if you have a 1:1 ratio, so if your M+2 is the same height as your M peak, that's bromine. And the reasoning behind that is that chlorine and bromine both mainly exist as 2 isotopes. Chlorine tends to be 35 and 37. Bromine is 79 and 81. That's why chlorine has this 3:1 peak, because 75% of chlorine is chlorine 35. 25% is 37, and then bromine, it's split between 79 and 81, which is why you will have the molecular weight in the periodic table is listed as 80. But if you have a bromine, you should consider the molecular weight as 79 for later calculations. Now, in my case, the molecular weight is even, which means that I have an even number of nitrogens. So just, remember that odd molecular weight equals odd nitrogens. And the next step, since we've gone through this, is just calculating the amount of carbons you have. Now, for my MS, I've been told to use the M+2 and M+3 peaks to do this. Unless it says to, what you should be using is M and M+1, which is your molecular ion, and then the M+1 just right next to it. And you should be using the abundances, not the molecular weights. So what you're going to want to do is take your M+1, in my case M+3, which is 2.4. So you have, 2.4. And you're going to divide that by the M+1 plus the molecular ion peak. So 2.4 plus 26.5 is 28.9. Yikes. Okay, and then once you do that, that is going to tell you the percentage of heavy C. So percent, I'm going to run out of space, C13. And then from there, you're going to divide your percent of C13. You divide that by 0.8 0.011 because they're about 1.1% of all carbon is carbon-13. Let me do the math quickly. I don't have the number on me. So 2.4 divided by 28.9, and then you're going to divide that by 0.011, and that gives me about 7.55 C. So obviously I don't have 7.5 carbons. This is mostly an estimate, so I would start by looking at structures with 7 carbons and 8 carbons, and then just kind of try to narrow down from there. But that's going to be pretty easy since I know I have a chlorine, since you see the M+2 is about a third the height of M. And I'm pretty sure I don't have a nitrogen, but I could have 2 in theory. So what we're going to do to calculate our chemical formula once we've got all of this information is we're going to take our molecular weight, which is 140, and then we're going to subtract all of the things we know are there. So first off, we're going to subtract 35 for the chlorine, and then we're going to subtract however many carbons we think we have for this formula. So we'll start with 7 times 12, which is the molecular weight of carbon. And that is going to give us, okay, so 140 minus 35 minus 84. So that gives us 21, which means we have 21 mass units left over. So I know we don't have a nitrogen because 2 nitrogens is 28. So we could have 21 hydrogens, which wouldn't really make sense because that would be more than are possible for this amount of carbon. Or we could have an oxygen. So in that case, we're going to have minus 16, which gives us 5. So we have C7H5O, Cl. Or if we just take this at face value, we have C7H21Cl. So those are our 2 possibilities for 7 carbons. For 8 carbons, it's the same idea. 140 minus 35 minus 8 times 12, which is equal to 9. So that leaves us with only just having hydrogens. So you have C8H9Cl. So these are kind of like the 3 possible chemical formulas that are close to what we've calculated. From this, the only way to know for sure is looking at your IR and your NMR. But don't stick too close to your carbon calculation. If none of those formulas ever make sense, you can kind of push into maybe it's 6 carbons, maybe it's 9 carbons. It's just an approximation. I hope that is helpful for anyone that needs a little bit of MS guidance. If you need a hand, just ping me, I guess. But yeah, hope you have a nice rest of your day.